Hello. Tell me please if my audio is clear. Hello.
Hello.
Okay. I think so my voice is clear to everyone. So we are good to go.
Okay. I think so. My voice is clear to everyone. So we are.
Nice, 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 nice. It is working fine. Okay. Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good. So till now we have entered into the optics section. Okay, we have started optics in the last lecture only. We have started from reflection. We have studied about the basics of those things, and majorly in the first lecture we have covered about plane mirror. Majorly we have covered about plane mirror. In this lecture we are going to understand everything about the reflection from spherical mirror. Reflection from what? Spherical mirror. Correct. So are you excited? All those things, mirror formula, magnification formula, both kind of magnification, transverse magnification, what is longitudinal magnification, image formation, how image is formed, position of image, multiple combination of mirrors will also see, like concave, convex you have combined, concave you have combined, plane mirror and concave mirror you have combined. Then what will be happening? All these things we are going to understand in this lecture. Okay, so are you excited to learn something new? So be ready with your pen and paper and let's begin the lecture without wasting any further time. Okay, so let's begin. See, now firstly you have to understand. Okay, wait a minute, let me handle this little bit. Firstly, let me clear what do you understand by spherical mirror. From where actually spherical mirror is coming? These are the basic things that you already know. In your basic classes, in your colleges, you have watched a lot of times spherical mirrors. So you have watched about it. It's not like something. It is very new. Okay. Once again, let me check if voice is clear. Fine. So spherical mirror is cutted out from a spherical surface. A big spherical surface is there, and a mirror is cutted out from there only. A mirror is cutted out from there. Let's suppose this is a spherical surface. This center point is called as center of curvature. Center of curvature. And this complete distance is called as what? Radius. This complete distance is called as what? Radius. Now, for making a mirror, what we do? We cut this much of the portion. We'll cut this much of the portion and we'll be taking it out. And we will do what? We will polishing one of the sides. We'll be polishing one of the sides so that you know that in plane mirror also we are always used to polish one side so that light cannot go in the other side of the mirror. It will be remaining in the same side that because we are performing what reflection. We are understanding reflection. Now depend on the side on which you are doing the reflection, you will be having two kind of mirrors. Let's suppose for a moment understand, let's suppose my hand is like this. I think that it is clear. One side it is inside portion, one side it is outside portion. This is exactly what I have cut it out from here. On the minor side I am telling you, if your reflecting side is inside portion, if your reflecting side is inside portion, that means you have polished the outside portion. That means this kind of mirror is called as what? Tell me. Concave mirror. And if this side is polished and reflecting side is this one, then it is called as what? Convex mirror. Very basic difference that it should be very clear to you, because from the basic classes you are studying about it. It's not something new. Okay. Some important points that you should be knowing. Center of curvature, this center is called as the center of curvature. Radius of curvature, this radius that you are having, this is called as what? Radius of curvature. Further, if you are going into it, you will be having pole is what? It is acting like a origin point. Okay, yeah, from every point calculations we are doing from the pole reference, it is taken as a reference point in all the calculations that we are going to do pole. Then we are having principal axis, this axis on which all these points are lying. Center of curvature, focus also, we'll be watching about focus also. This pole, all these points are lying on the on a same line. That line is called as what? Principal axis. Radius of aperture, the aperture that you have cut it from here, the aperture that you have cut it from here, the radius that will be present here, this radius, not the radius of curvature, this radius is called as what? Radius of curvature. It will give you an idea. Radius of aperture will always give you an idea how bigger your size of the mirror is actually. Okay, this is always going to give you about the idea of the size of the mirror. Okay, radius of aperture. Now there are two kind of rays will be there. One is what? Marginal rays, and second one is what? Paraxial rays. Marginal rays means what? The angle at which it is coming on the mirror is greater than 10 degree. But majority of the calculations that we are going to do in this chapter are for paraxial rays. For paraxial rays. Now what are the paraxial rays? Paraxial rays are those kind of rays who will subtend an angle very small at this, very small at the mirror. Okay, here you can see the condition for paraxial ray. It is very small angle theta. Okay, and this will be, and all the derivations that we used to do, we used to assume that all the rays that we are assuming are paraxial rays. That means what we are going to assume, because very soon we are going to see about mirror formula, how mirror formula was derived. This was also assuming the paraxial ray, because we will assume that the theta is very small. When theta is equal to very small, we use the property of sin theta is equals to theta is equals to tan theta. This can be written for all the things. Okay, now focus. What is focus? Focus is a very important point in our complete calculation. Okay, focus is defined as f is equals to r by 2. R by 2 means what? Half of the distance of the radius of curvature. If you are doing, you will be having what? Focus. When the rays are coming parallel, when the rays, incident rays, are paraxial also, if the incident rays are paraxial and theta is very, very small, then the point from where this ray is going to pass is called as focus. After reflection, see, definition wise what it is: if the incident rays are paraxial, that is the first condition, it should be paraxial. Angle of incidence is small, automatically it will come into the scenario, and parallel to the principal axis. And if the ray is parallel to the principal axis, here you can see a ray is coming, and this theta, already I am assuming that it is very, very small and it is parallel. They will meet or appears to meet at a single point, that is known as focus. They will appear at a single point. Let's suppose from here also, if some light is coming, paraxial ray is coming, it will also pass from the focus. So all those paraxial rays that are coming parallel to the principal axis, all those points will be passing from a point, and that point will be called as what? Focus. That point is called as what? Focus. Is it clear? समझ आया इतना? Wait a minute. Fine. So let's move to the next point. So this is the diagram that you will be having. I have already told you. For a concave mirror, what kind of mirror point will be there? These parallel rays are coming and it is going to pass from the focus. Simple. And what about convex mirror? Convex mirror, it is interesting. For convex mirror, it is interesting. What is for the convex mirror? Rays are coming like this. Rays are coming like this. You know that it is not a converging mirror, it is actually a diverging mirror. It is a diverging mirror. That means rays, if you are drawing the normal, this will be the normal, and rays is going to pass like this. Now if you can see, actually these rays are never going to converge at a point on the same side. It is never going to converge at a point. So that's why we say that convex mirror, it is not going to form a real image. For forming a real image, what was the condition that was required? For forming a real image, the condition that was required is, tell me, is my face, I think, is not clear. Okay. So for watching it should be, if it is real, that means the rays should be actually converge at a point, not it should be appear. So here if I will draw the ray diagram, on this side it is not going to converge at a point, but if I am going to subtend both these points, it is going to intersect at a point, and that point is called as what? Focus. Because these are paraxial rays and parallel to the principal axis. Clear? In this we will be discussing about ray diagram as well in complete depth. Now, a kind of variety of question that usually come, a sun will be always be given to you, and at the earth they will be subtending some angle, and a lot of time that a question is asking you. So what is actually happening? This is your sun and you are at earth. Let's suppose this is sun and you are at earth and you are watching, perceiving the rays from here. So rays will be coming parallel, that is sure, but it is not fixed that it is going to be parallel to the principal axis also. Rays that are coming, that is going to be for sure parallel, and it is paraxial also. Theta angle will be very small, angle will be very small, because it is coming from a that much of far distance. Whenever we increase the distance, what happens? Always the angle decreases, always the theta decreases. Okay, so what you will be saying, so this kind of thing will be happening, but rays will not converge at the focus. This time what will be happening, here is the diagram that it will explain you. See, rays are coming parallel, rays are coming parallel, and it is coming to the focus. It is some rays are coming to the focus and passing from the focus, because it is coming from infinite distance, it is going like this and converging at a point that is not focus, but it is lying on the same line of the focus. So this actually called as, it is converging at focal plane. This is getting converged at a focal plane. We name this as focal plane. Okay, and how we can calculate this? Let's suppose the distance, if from the point of focus where the distance it is going to converge, it is, let's suppose the distance is h. Define tan of alpha. The angle that is subtended here is what? Alpha. कैसे define करोगे? Perpendicular upon this is the perpendicular, this is the base. Perpendicular is h divided by r by 2, and r by 2 can be said as focus. That means what you can say, and this alpha is very small, that means h can be written as focus into alpha. H can be written as focus into alpha, because, and this alpha, one very important point, this alpha is in radians. This alpha is in radians. This is the way you will be solving this. One variety of question also, let's understand by your question. Here is the question, better you will understand here. See, question is saying, telling you what, if a ray is coming from sun and is incident on a spherical mirror of focus is given as 10 centimeter. Okay, as shown, find out the diameter of the image of the sun. You have to calculate what will be the diameter of the image of the sun. It is coming here, and this way it is going to find the, this way it is going to make the diameter. So for making the diameter, you have to calculate the value h. You have to calculate the values. Here a lot of rays will be coming from sun, and here it is coming, and then here they are all are converging, all of them are converging, and this plane I have told you already, this is called as focal plane. Actually, it is a property of pole. Whatever the angle it is incidenting, it is going to reflect it back on the same angle. That means if this angle is 1.5, this angle is also 1.5. Now define tan of 1.5 will be what? Perpendicular, that is h divided by the focal length, that is f, and f is equals to 10. F is equals to 10. So tan of theta, now I can say theta is, when theta is very small, then what I can write? Tan of theta, if theta is very small, tan of theta is equals to theta, and it is equals to sine of theta. Okay, this is the relation that you can apply directly. So it will become what? 1.5 is equals to h divided by 10. Now h can be written as 10 into 1.5, and I've told you that this 1.5 will be written in radians. That means in, not in degrees. That means you have to multiply it by pi by 180 degree as well. So after solving all these things, what will the height that will be getting? Solve kar lena, it will become 15 divided by 180. That means it will be pi divided by 12 centimeter. This much of the height will be, that will be present there. Clear? This way you can solve all these kind of sun, and sun, majorly the questions will be coming like here it is given a sun, and what will be the angle, what will be the diameter, this kind of questions is usually asked. Okay, correct. Now let's come to the first and the most important topic, that is mirror formula. Okay, mirror formula. Wait a minute. मैं गोरा नहीं लग रहा है यार. Now is it, I am looking fine? Little bit, little. Okay, now it's little bit fine. Okay, fine. Let's move further. See, how you'll be deriving the mirror formula. Anyways, what is a mirror formula that you have already studied in basic classes? 1 by v plus 1 by u is equal to 1 by f. Now let's today understand what actually how it is derived. Okay, it is very interesting. Just listen here. You have to apply a little bit of maths, of course. Okay, here it is your object kept. This is your object, and it is a ray diagram that is drawn. Here is the normal that is passing, and for any kind of perpendicular, if you are drawing on a circle, it is always passing from the center. So this normal is passing from the center of curvature point. Okay, and if this angle is theta, this angle is also theta. Angle of incidence is equal to angle of reflection. Law of reflection is valid, and after that the image is forming somewhere here. Image is forming somewhere here. Okay, these are the points, and I have named some angles. Here it is alpha, beta, and gamma. I've used the exterior angle property. What you call that property? When this kind of triangle is there, let's suppose this one is theta, this one is alpha, and if I will ask you this one, what will be gamma? You write that theta plus alpha. Arvind sir से पूछना क्या बोलते हैं इसको? This is the property that is present in mass. Now you tell me in the comment section what is this property named as. So I'm using that property in triangle OMC. Now देखो ध्यान से देखो triangle OMC. This triangle is there. Okay. Now if I have to write beta, how will be writing beta? Beta is equal to alpha plus theta. Beta is equal to alpha plus theta. Now second triangle is important, CMI. What is the triangle? CMI. And in this triangle CMI, I have to write gamma. कैसे लिखोगे gamma? Gamma will be written as beta plus theta. Gamma will be written as beta plus theta. और क्या करो? Equation 1 minus equation 2 कर दो. ठीक है? These two triangles you have to understand. This is mandatory to take. So the result that you will be getting after subtracting both these equations is gamma plus alpha is equals to 2 beta. Gamma plus alpha is equals to 2 beta. Now if these angles are very small, all these angles you have to assume that here is the assumption given. All the angles are very small. If all these angles are very small, this distance NP is also negligible. That means at the place of N I can do, because I have dropped a perpendicular from there and there will be some distance, but that is very negligible distance because the angles are very small. यहाँ पे बड़ा दिख रहा है because I have to explain. Otherwise, these angles are literally like negligible. Okay. So now what you'll be doing, you can write, if angles are very small, you can write theta is equals to tan of theta, or also you can write sin of theta. Anyways, we will be using only theta is equal to tan of theta. तो लिखो, you can write gamma is equals to tan of gamma plus alpha is equals to tan of alpha is equals to 2 times of tan of beta. Now tell me what is tan of gamma? Tan of gamma, this is gamma perpendicular upon base. That means what you'll be writing? M n divided by gamma perpendicular upon base. Base what will be writing? IP. I've told you now, because this distance is very negligible, I will take the point P in consideration. Plus tan of alpha. Alpha what will be writing? Mn again divided by, what is the distance you will be writing? Tan of alpha O to P is equals to 2 times of tan of alpha. Again you will be writing Mn alpha. This is the angle alpha. Sorry, beta you are writing. This is the perpendicular. When the base what you will be writing? What this distance is called as? How much the distance? Anyways, write it CP. CP you will be writing as the distance. Now solve it. Mn will simply get cancel out. What are the things that are left? IP. I to P. Can you say this distance is nothing but called as V, distance of image from the pole? This distance is represented as V. तो यहाँ क्या लिखोगे? 1 by V plus. यहाँ पे 1 by OP. O to P. Can you say this is represented as U? Correct? Represented as U is equals to here 2 divided by CP. What is this CP? This is nothing but the radius of curvature. Yes or no? So what you can write here also, it will be radius of curvature. Remove this 2 here and write it R by 2. And what is R by 2? R by 2 is nothing but focus. That means what is eventually our mirror formula is going to be equals to 1 by V plus 1 by U is equals to 1 by F. But now this was a basic thing, but how you have to remember this result, that is a different case. You will be remembering this result as like this: position of image directly. 1 by V, how much you can write? How you have to remember that result? 1 by V is equals to 1 by F minus 1 by U. That is equals to, here what you can write? It will be U minus F divided by U by F. That means V, just make the reciprocal. How you will be remaining? It is UF divided by U minus F. You have to solve the question using this result. Okay, not this one. It is always, usually it is fast. Just only you have to understand what is the sign convention, that I am going to tell you how to take the sign convention. Only this complete optics. If you understand the sign conventions, nearly 80% of the battle you have already won. 80%. Literally, I'm telling you. For the basic competitive exams, NEET, JEE, board, anyways, you have to understand the derivation. That's it. So CET, all these things, just 80% of the game is done. Sign convention. Okay, formula तुम्हें पहले पता है, but where you will be stuck in sign convention. So please focus on sign convention. Still, if you are having any doubt, please comment down in the comment section. I will be replying for there. Now, if I'm talking about sign convention, simple sign convention, nothing very extra I'm going to tell you. Okay, not a very any special thing I'm going to tell you. Very basic we will kept, and I will explain you from the questions as well. It will be much better. See, if this is a mirror, what this point is called as? This point is called as pole. Let's suppose here is some object. Okay, what will be happening? Actually, two things that you have to always remember. Direction of incident ray is always taken as positive. Direction of incident ray is always taken as positive. Second thing you have to remember, that principal axis acts as x-axis. This principal axis is going to act like a x-axis. That means if anything is above this, it will be positive. Anything is below this, it will be negative. Conventional. Lot of time you will be making mistake. You will be assuming this as origin and this side as negative, this side as positive. Majority of the cases में ये होगा भी. But still, this is not completely true. इसमें पक्का mistake करोगे. Remember, only the direction of the incident ray is always positive. For example, here if I will tell you, what will happen? Rays will be going like this. तभी तो reflection होगा. That means what is the direction of incident ray? I can say this is the direction for the incident ray. That means I will take this direction conventionally as positive and this direction conventionally as negative. Simple. समझ आया? So this is what, and now let's apply this in some question and then try to understand क्या होता है. ठीक है? See the question. What the question is telling you: find the position of image when the object is placed as shown in the figure. Here is your object kept. Now see, what is this scenario? This kind of mirror is there. Okay, and this is a reflecting side. This kind of mirror is there. Okay. Now see, doesn't matter what kind of mirror is there. You know that what is the position of image, that is UF divided by U minus F. That means you just have to write what are the conventions that you know. That's it. Question is done. Now see, here is your object. For reflection, light have to come like this. That means I can say this direction is getting positive. This direction is getting positive. If this direction is getting positive, ultimately this direction is going to be negative. And all the calculations we do from the pole. Now calculate. Tell me, what is the distance of object? You will say 10 centimeter. That is very good. But positive or negative? From pole, you have to go in positive direction or negative direction. Sir, I have to go in negative direction. I have to go in negative direction. Correct? So go in negative direction. Position of object, you will be writing minus of 10. Focal length is also going to be red because this is the kind of shape you are having. That means center is going to lie on the right side. That means focal length is also negative. Focal length is minus of 20, here minus of 10, minus of 20. So what will be the result that you will be getting? Here it will become 200 divided by here minus of 10 plus of 20. That means here it will become 10. It will be cancel. Answer will be coming 20 centimeter. That means kaha image banega? Now where the image will be forming? Image will be forming on the other side, because it is showing also one more important, that it is the value that is coming here is positive. If the value here coming is positive, that means image is forming on the other side, because this side is taken as positive. This is the distance where the image is getting formed at a distance of 20 centimeter. समझ आया? At the distance of where? How much? 20 centimeter. Clear? Very good. एक और क्वेश्चन सॉल्व करते हैं. लेट्स ब्रेक ऑल दीज फियर ऑफ साइन कन्वेंशन. एक और क्वेश्चन करते हैं. एनीवेज दिस इज नॉट आवर क्वेश्चन सीरीज. इन क्वेश्चन सीरीज ओनली वी आर गोइंग टू फोकस ऑन द क्वेश्चंस, बट स्टिल वी आर हैविंग सम क्वेश्चन ताकि यू डोंट हैव एनी डाउट रिमेनिंग. सी अगेन यू हैव टू फाइंड सिंपली द पोजीशन ऑफ द ऑब्जेक्ट. व्हाट इज द फॉर्मूला? बस वो लिखो. v इज इक्वल्स टू uf डिवाइडेड बाय u माइनस f. Sir, I know only this much. Okay, no problem. See, this kind of shape you are having, that means center is going to lie on the right side. सही बात है, correct? See, if this is the object, can you say this kind of, if I have to perform reflection, that means I have to go in this direction, that means can you say this direction is automatically become positive, and if that direction is positive, this direction is going to be negative. Now tell me about u is 40, but plus or minus from the pole you have to go in the plus direction or minus direction. You have to come in minus direction. That means you will be writing what? Minus of 40. What about the focal length? For focal length, here somewhere focal length will be lying at how much distance? 30 centimeter. For calculating focal length, you have to go in positive direction, negative direction. Positive direction, that means you will be writing what? Plus of 30. जब बाकी यहाँ लिख लो minus of 40 plus of 30. Here what will be writing? Minus of 120 divided by minus of 70. 0 cancel. 12 by 7. Sorry, one more 0 will be coming. That means 120 by 7 centimeter. The answer will be coming. And what also this answer is reflecting, if it is coming positive, that means you are having what? You are having the image somewhere here at a distance of 120 divided by 7 centimeter. समझ आया? Is it clear? Fine, very good. This way, once you understand sign convention, I have already told you, half of the battle you have already won. Yeah, sign convention is the biggest thing that you have to understand in optics. After that, you will be just enjoying with the things, then experimenting, then take variable things, go to advanced question also, no problem. Okay, but firstly understand the sign convention. So let's discuss about the real and virtual images. Let's talk about real and virtual images. See, reflecting side, I've told you, just remember one thing. Reflecting side conventionally, if the object is real, that means image for being real, it have to form on the same side. If object, real object, I'm telling on all the cases as of now, I'm talking about real object. If real object and real image and the image are on the same side, it is real image. If real object and the image are on the opposite side, that means it is virtual. It is virtual image. And vice versa, it will happen in reflection. In reflection, it will just reverse. I will tell you there, but as of now, make a note and write. This is a very, very important line that I'm telling. If it is a real object, okay, it is a real object, and rays are actually converging at a point. Rays are actually converging at a point, that is real image, and it both are at the same side. That's why it will be what? Real object, real image. See here. Here a ray, it is a real object, but image is forming on the other side. If image is forming on the other side, that means it is appear to converge at a point, and that's why it is called as virtual image. It is called as virtual image. And I've already told you, if they are on the opposite side, that means there is some gadbad, and if object is real, then the image will be virtual. Okay, again you have a question. See, this time what you'll be saying, what about the nature also? You have to, anyways, in the first two questions also you can tell me about the nature. Let's again practice the same thing. V is equals to uf divided by u minus f. Batao. Now you tell me, what is the position of object? What is the distance given for the object? Find out the position of nature of image. Position of object itself is not given. Some missing value is there. Because the distance of object is not given. How will we calculating? See, it has been missed that it was given as 20 centimeter. Take it 20 centimeter and then solve it. This distance is given to you is 20 centimeter. अभी बताओ पहले तो firstly judge that which direction is positive, which direction is negative. This is the object. That means this direction will be what? Positive, and this direction will be what? Negative. Correct? Now लिखो V is equals to U. For calculating the distance of object, you have to move in negative direction or positive direction. I will say from the pole I have to move in negative direction. And how much I have to move? Minus of 20 into focal length. Where the focal length is lying, focal length, this kind of mirror is there. This side is plated, polished. That means focal length is also coming on the negative side. And how much? Minus of 40 divided by minus of 20 plus of 40. It will be how much? 800 divided by 20. That means answer is going to be plus of 40 centimeter. Plus of 40 centimeter, that means image is forming on the other side, because this direction is for positive side and it is coming plus of 40. That means this image is what? Virtual. This image is what? Virtual image. समझ आया? थोड़ा सुन पे I am learning some Kannada words. Now, real and virtual object. When you will be saying, sir, it is real object, and when you will be saying, sir, it is virtual object. See, there is a very simple way to judge that. When incident rays appear to converge at a point, then the object formed is known as a real object. When the incident rays are actually appear to converge at a point, okay, actually converge or diverge also, okay. So you can see here it is a point, and real way may rays are coming out from there, okay. So it is defined as what? The real object. And take the second case. Here you can see light rays are coming from some infinite distance. Light rays are coming from some distance that is not clear. So it is appear to this point here, when where it is converging, it is just appear to getting converged. So that's why it is defined as the real object. This will be defined as what? Real object. When you will be taking the combinations now for two mirrors, then it is going to come in lot of use. Then it is the maximum cases where we are going to use it as virtual objects also. Otherwise, a very less time it will be having virtual. Here the statement is also written: when the incident ray appears to diverge from a point, then the object is known as real object. That is appear to see. From here it is actually diverging to the point, that means it is real. And when rays are appear to converge at a point, simply याद रख लो, जब कन्वर्ज हो रहा होगा कोई रे, टू इंसिडेंट रेज, इंपॉर्टेंट इज इंसिडेंट रे, नॉट द रिफ्लेक्टेड रे, टू इंसिडेंट रेज अगर कन्वर्ज हो रहा है तो वो क्या है? वर्चुअल. एंड टू इंसिडेंट रेज अगर डाइवर्ज हो रहा है एक सिंगल पॉइंट से, दैट पॉइंट इज व्हाट? रियल ऑब्जेक्ट. क्लियर? अब 4 स्टैंडर्ड रेज है यार, तुम्हें पता होगा आई गेस दैट बेसिक क्लासेस में रे डायग्राम्स के बारे में तुम लोगों ने सफिशिएंटली पढ़ा है. व्हाट आर दोस 4 इंपॉर्टेंट रेज? आई विल टेल यू क्विकली. One ray, when the, and all about all those 4, it is reflected here. And let's go in the sequence only with the color sample also, because we have multiple colors and I enjoy all these colors. If the incident ray are parallel to the principal axis, what will happen? If the incident ray is parallel to the principal axis, अभी हमने discuss किया. If the incident ray is parallel to the principal axis, the light ray will always pass from the focus. पहला ray इस टाइप का होता है. This is the first kind. Second kind, if the incident ray passes through the focus, what will happen? If the incident ray passes through the focus, after reflection, what will happen? It will become parallel. Vice versa, अगर parallel है तो focus से pass करेगा, अगर focus से pass करेगा तो parallel हो जाएगा. Simple. Next one, if the incident ray passes through the center of curvature, if incident ray is passing from the center of curvature, it always retraces its path. If अगर इस पाथ पे गया तो वापस इसी पाथ पर रिवर्स हो जाता है. दिस इज द थर्ड काइंड ऑफ रे दैट विल बी हैविंग इन, एंड मच सिमिलर विल बी हैविंग इन लेंस आल्सो. सो बेटर इफ यू आर अंडरस्टैंडिंग हियर, you are gripping the concepts here, then it will become easier for you in that case also. If the incident ray falls on the pole, then what will be happening? So it is the property of pole. If the incident ray is falling at some angle theta, it will reflect the light ray at the same angle theta. No problem. It will reflect the same thing at the same angle theta. If incident ray is theta, reflected ray is also theta, and vice versa. Same kind of things you can say for the convex mirror also. Just here, sometime here virtual rays are forming, so you practice it by yourself. You will be having, I will be discuss majority of the things for concave mirror. Okay, now let's come to the magnification. Case. What is magnification? Magnification actually tells you about the ratio of the height of image and height of object. How much times I am bigger than. Let's suppose your height is 2 meter and you are getting your image as 4 meter. Okay, somewhere you are watching a spherical image, your image is having 4 meter. So how much times it is more than you? Actually, how much time is it more? 2 times. That magnification, what will say? Sir, I am having my image 2 times bigger than the mirror. That is called as simply as magnification. So there is some formula that you have to remember. And what is that formula? Let's see also. See, here it is a diagram that is drawn properly. Here is the object that you are having, h naught. It is represented for the height of object. And after ray diagram, it is reflected that you are having the image somewhat like this. This is hi. Okay. So in triangle APB, in triangle A, see points, these triangles are very, very important. Okay, in triangle A, P and B, ABP, sorry, ABP. If you have to define tan of theta, how you will be writing? Batao. Tan of theta perpendicular upon base. What is the perpendicular? You will be saying h naught. And what is the base that you will be saying? it will be U. It will be what? U. In triangle A dash, B dash and P, this triangle A dash, B dash and P, if again I will, because A ray diagram is clear now, one ray is going parallel passing from the focals and second ray is passing from the pole, that means it will make the equal angle, subtend the equal angle. So second, if I will ask you, tell me about theta, how will be defining tan of theta? Tan of theta in this one, this is the height of image hi divided by what is this distance, this distance is called as V. So if I am combining both these, what I can write, h naught by u is equals to hi by v. From here I will get the relation, because magnification basically what, height of image divided by height of object, that is what you also did. So height of object divided by height of image is equals to u by v, and we add a negative sign as well, because see, I've told you now that this principal axis is behaving like a x-axis. So if your object is upside direction, that means it will be taken as positive, but your image is forming in which direction? Negative direction. And for representing that negative direction, we used to add a negative sign. So in general, what it is written as, let me check, I have taken this ratio as wrong, I guess. It's not by u, hi by v, so h not by hi. एक second, height of object divided by u, correct? I have taken this ratio correct, but magnification is hi by ho, no? So it will become v by u, correct? No? So magnification net is called as height of image divided by height of object, that is the basic definition. And for this case is actually called as transverse magnification. Transverse magnification, because there are two kind of magnifications also. So transverse magnification, when the object is kept perpendicular to the principal axis, that is called as transverse magnification. This is equals to v by u, and there will be a negative sign. That's why, because it is reflecting that your object is above the principal axis and your image is below the principal axis. Clear? This is about transverse magnification. This is the formula. Sign conventions already I have told you. See, solve this question. Try to solve this question. What the question is saying. Let's solve it. First part question is asking you, consider the following ray diagram. Okay, ray diagram is given. Some ray diagram is given to you. Find the position and the nature of the image formed by the convex mirror. You have to tell what is the nature of the convex. Okay. See, these are the two rays that are incidenting. This is the incident ray, this is the incident ray, and these are the reflected ray, these are the reflected ray that is coming after ray. So see, if this is the direction for incident ray, firstly I have to check that I will say that this direction is positive, that means this direction will become negative. So पहले तो position find करते हैं where the image is actually forming. So V is also U F divided by U minus F. V, U, how much U is given? 60 centimeter distance of object from the pole, but plus 60 minus 60, for calculating the distance of object I have to actually move in the positive direction. And how much distance? 60 centimeter. That means I will write it as plus of 60. Now what about the focal length? Focal length is also going to lie in the positive direction, that means it will become plus of 20. Here 60 minus of 20, कितना हो जाएगा यहाँ? 1200 divided by यहाँ हो जाएगा 40. When you will be very efficient into this, उसके बाद time नहीं लगेगा तुम्हें solve करने में. So it will become how much? Plus of 30 centimeter. Plus of 30, that means you are going in this direction. That means this is the image position. And how much? Plus of 30 centimeter. अब check करते हैं. What about the magnification? What about the magnification? Magnification is what? Height of image divided by height of object is equals to minus of V by U. Now what is V? That is 30. And what is U? That is 60. And if I have to calculate height of image, I will be simply doing what? 1 by 2 is will be this ratio multiplied by 4. It will be how much? Minus of 2 centimeter. Minus of 2 centimeter will be the height of image. That is what I can say about it. Is inverted, because these kind of images are called as what? Inverted images. What else I can comment about it? That it is diminished because the size is less than the actual object that is kept there. So what is the size that we call this kind of images? It is called as diminished size. Okay, so these many things you can comment from here. Now see the second kind of magnification, that is longitudinal magnification. Now what is longitudinal magnification? Last case, if you remember what I've told you about transverse magnification, when the object is kept perpendicular to the principal axis, it is called as transverse magnification. But if the object is kept along the principal axis, then it is called as longitudinal magnification. Then it is called as what? Longitudinal magnification. So let's see what is the longitudinal magnification. See, an object is kept like this, b to a. This is the length of object. Anyways, we are going to see an formula also, but before that, let's understand the concept, what the concept is saying. Okay, and here what we'll be saying, this is the image that you will be going to get for this one. This is the image, and we are talking here about length, not the height, because height is what calculated perpendicular. Here we are discussing about the length of object and length of image. So what you will be saying about magnification, magnification is equal to minus of length of image divided by length of object. Okay, so better way to understand this, there is an example that is going to perfectly explain you about this question, what this question is actually trying, and what actually we are trying to derive there also. Okay, see, very beautiful question. Let's understand. See, there is an object kept BA. Okay, length for that object is 30 centimeter. Okay, I want to calculate 30 centimeter is placed in front of concave mirror. Concave mirror is there. Focal length is given as this 20 centimeter. This point A is at 60 centimeter. That means automatically this point B will be at 90 centimeter. Length of the mirror, focal length of the mirror is 20 centimeter. That is also given. Find the magnitude for A and B. Find the magnitude. Find the magnification for A and B. What is a magnification? How are we saying, students, magnification? Magnification will be simply length of image divided by the length of object. And length of object already I know. Only thing that I have to know is magnification for length of image. That is what actually I have to calculate. And length of object already I know, that is equals to 30 centimeter. Correct? So let's focus on the length of the image. How we can calculate? It is looking complicated. So let's break it point by point. Okay, let's break it point by point. Calculate firstly about position A. What will be the position of image of A? So let's calculate firstly for A. And this formula is already we are going to know how to use. Now see, just the direction is positive. This is the object. That means of course this direction will be the direction for the incident ray, that will be taken as positive. This direction is going to be taken as negative. And for calculating the distance of object, distance of point A from the pole, I have to go in the negative direction. That means what I have to write, how much in negative I have to go? Minus of 60 U into F. Focal length is minus of 20 divided by minus of 60 plus of 20. कितना आएगा ये? Check करो. It will be coming as minus of 80. Minus of 80. Actually, it will become plus, and here it will become minus of 40. That means it should become as, if my calculations are correct, it will be coming as minus of 20 centimeter. Cross check it. Arey yaar, it will be 1200, no? 1200. It will be minus of 30 centimeter. According to me, if I am getting wrong in the calculation, please tell me in the comment section. Object A, image of point A is, let's suppose A dash, and it is at a distance of 30 centimeter from the pole. Okay. अब देखते हैं कि point B का क्या आ रहा है. Where the point image of point B is lying. And can you say, अगर मैं उसके बाद difference ले लूँ तो मेरा length of image आ जाएगा. I will be having the length of image if I am taking the difference. Correct ना? So point B, let's calculate what will be the image distance for point B. Firstly, calculate what is the U. 60 plus 20 plus 30, actually 30, that means 90, and 90 in negative direction, minus focal length again minus 20 divided by, it will become minus 20 plus of 70, that means it, I am directly writing it as minus of 70, minus plus of 20 at the place directly I am writing. This cancel. Here what you can do, this minus is also cancelled, and here what you will be writing it as negative of how much? This will become 180 divided by 180 divided by 7. Correct? If I am wrong, then please make me correct. Okay, 60 30. I think that it is correct. Correct. Okay, 180 by 7 centimeter. That means, can you say it? 180 by 7 means what? 180 by 7 means what? It is smaller than 30. Smaller than 30. It will be roughly around. It will be for sure less than 30. That means your B dash. Your B dash is lying somewhere here, and the distance is what? 180 by 7. So अब calculate करते हैं length of image. How much the length of image? So how I can calculate length of image? Can I say I will subtract 30 minus 180 by 7? That means how much it is coming? Can you say it is nothing but 30 by 7 centimeter length of image? Length of image is 30 by 7 centimeter. Now just put it in the magnification. Length of image is 30 by 7 and length of object is already 30. And then there is a negative sign as well outside. So what you'll be doing? You'll be just writing it as 30, 30 cancel. Magnification will be coming minus of 1 by. Magnification will be coming minus of 1 by 7. Now this is one method, but when this length of object will be very small, when this length of object will be very small, we use an approximation. We use an approximation. What is that approximation? I will tell you. We use an approximation and directly we write the result. Directly we write the result as, let's see here, like example, it is given as 1 millimeter. That means negligible. That is position, I can say for A and B both are same. And in that case, what we define the formula, that is m is equal to minus of v square by u square, and it can also be written as length of image divided by length of object. So directly in these kind of cases you can apply, but there is a condition that this distance should be very small, negligible in comparison to this one. So here it is a fair amount of difference. Here it is 1 millimeter and here it is 20 centimeters. So there is a decent difference between them. Clear? Now see about the ray diagram. Let's quickly recap this ray diagram. In basic classes already you have studied about ray diagram. When the object is kept at infinity, parallel rays will be coming and passing from the focus. That means object distance infinite, image distance focus. Object distance infinite, image distance focus. Okay. Nature कैसा होगा? Point size होगा, real image बन रहा है. For this one it is real image because object and image both are in the same side. Clear? Second case, when object is kept beyond C, position of object beyond C, where the image will form, one ray will be going parallel passing from the focus. Always take a ray that is passing from the focus and make the second ray passing from the focus, make it parallel. That means I can say the intersecting point will be becoming the image point, and I will say the position is between C and F. The position is between C and F. What about the nature? Again, it is a real image because both are in the same side. It is inverted image, and even it can be called as diminished image. It is also called as diminished image. Clear? Next position, when you are keeping the object at the center of curvature only, take a ray that is passing parallel and make it pass from the focus, and take another ray passing from the focus, make it parallel. When you will be drawing the ray diagram accurately, it is going to converge at the same point where the object is kept. That is called a center of curvature. Many of the students will be remembering this. Center of curvature have the property, if the object is kept at center of curvature, image will also form at the center of curvature. What about the nature? Nature is real, same side it is present. It is inverted and it will be same size. This time it is called as same size. Come to the next case. You can observe that as soon as object is coming closer to the mirror, image is going farther from the mirror. This is also one very important thing that you can notice. Now come between C and F. If you are keeping the object between C and F, image will be forming beyond C. You are coming closer, image is going farther. Move more farther. Keep the object at the focus. When you are keeping the object at the focus, image is forming actually at infinite distance. Because what will happen, one ray you will be taking parallel, it will be passing from the focus only. Second ray take from the pole and it will also become parallel. So we say that it is going to meet at some infinite distance. Nature will be real because again image is forming at the same side. Inverted image and enlarged image, size of the image will be very high. Last case and one only exception in case of concave mirror, when the object is kept between focus and pole. When object is kept between focus and pole, actually when you will see the rays are never going to meet in the same side. So we have to converge both these rays and it appears to converge at this point on the other side of the mirror. That's why we call about this point as it is forming the image behind the mirror. Nature virtual because it is not on the same side. And what about the size? Size is enlarged and erect, not inverted, it is erect. It is the only case where this kind of things are happening. So it is an important case also. So I hope that you are remembering this all these results. Now here it is a case for velocity of image. Velocity of image easily you can calculate. How will be relating velocity of image? Both the directions I will tell you in one go. Like you have seen now, for height of image divided by height of object is equal to minus of v by u. Same way you can write velocity of image divided by velocity of object. This is a case for transverse velocity. That means velocity is perpendicular to the surface. If your velocity is along the surface, that means longitudinal velocity. That means you will be saying what? It is minus of v square by u square it can be written as velocity of image divided by velocity of object. See, same formula you are going to get from here also. So it is a very easy case. If you know how to write the magnification, you can easily write the this results also. If the question is asking you about with respect to mirror, just write the same formula as with respect to mirror. Again, you will be able to solve the question, because this kind of question we have solved in plane mirror. If you remember, in plane mirror we have solved this kind of question. So here it is a question. Let's quickly solve this question. Okay, let's see. See what is the question is saying. A position is given, focal length is given. Okay, firstly let's calculate where the distance or where the image is actually forming. Mirror is also moving. Okay, so let's firstly calculate what is v. V will be uf divided by u minus f. पहले तो ये calculate करो आराम से. U will be how much? Minus of 30, because object is obviously this is in negative direction. Now what about f? F is minus of 20 and here it will be minus of 30 minus of 20. तो ये होगा कितना? This will become positive and it will become 600. Correct? 600 divided by, यहाँ पे हो जाएगा ये minus of 10. That means image will be formed as minus of 60 centimeter. पहले तो locate कर लो. Image is forming, this distance is 30. That means somewhere your image is forming and that is at a distance of 60 centimeter. Now calculate what is the velocity of image with respect to mirror. Now what you will be writing the equation? Velocity of object with respect to mirror is equals to minus of v square by u square into velocity of image with respect to mirror. कैसे लिखोगे? Well, you know about relative motion, it will be written velocity of object minus velocity of mirror is equals to minus of v square. V square, what you will be writing about v? It will become 60 square, 60 into 60, and what you will be writing about u, it will become 30 into 30. That means basically it is going to be 4 into velocity of, it will be velocity of image na here, and here it will be velocity of object minus velocity of mirror. Clear? After that, further solve it. What about the values that are given? From here what you will be saying, velocity of image you have to calculate, only velocity of image you have to calculate, minus of velocity of mirror. How much you will be saying? Minus of 6. Minus of 6. Here it is minus of 4 already, and inside you will be having velocity of object. Object is moving plus of 2 minus of 6. Clear? Now velocity of image will be equals to, here it is becoming plus, here it will become, I hope that I have kept the sign conventions correctly, plus of 6, it will become here minus of 6, और यहाँ पे क्या बन रहा है? See here, minus 6, it will become plus of 24. That means velocity of image is going to be 18. I think that I have taken some sign conventions wrong. Let me check it. You will be writing velocity of image minus 6. That is correct. Here it will be becoming 4. 2 minus of 6. Okay, here we have taken, this will become add up. So here it will become 8, and then you will be getting the correct answer. I've told you there is a margin of signs. If you are keeping the signs correctly, then you will be obviously having all the things we are going same. Just here it will become plus, because velocity of image you will be taking in negative direction. That's why you will be taking it as negative of the sign. Rest of the things are same. Is it clear? Now combination of mirrors. Now there are multiple possibility of combination of mirror. Either you can combine plane mirror, concave mirror, plane mirror, convex mirror, convex concave mirror you can combine, convex convex you can combine, concave concave you can combine. So lots of possibilities are there for the combination of mirror. So let's see what is the basic way to solve the questions. Don't need to get horrified from these questions. Very easy these are. Just solve one at a time and locate the image position also. That is the more important thing. Locate the image position. Okay. See, here is your object, and this is the distance of object that you will be getting. And M1 is the first mirror from where reflection is happening. For M1, what will be saying? This direction is positive. This direction will become negative. पहले calculate करो for M1 के लिए what is the position of the image that you will be having. U, what will be saying? This direction is positive. U, for calculation of object you will be have to come in negative direction, and how much? That is 30 centimeter. Minus of 30. It is a kind of concave mirror, that means you will have focal length that is negative, minus of 20 divided by minus of 30 plus of 20. How much it will become? Minus of 10. This minus my net, it is going to be minus, and this is going to be cancelled. Here it will be minus of 60 centimeter. What will be getting? Minus of 60 centimeter. अब क्या करोगे? Locate your image also. Here is your I1 is getting, and what is the distance from this mirror? It is equals to 60 centimeter. Now the reflection will be occurring from the mirror too. So when the image is forming, can you say after reflection, this rays will be somewhat coming like this, correct? So for this mirror, I can say this is going to, because now this is going to behave like object for mirror 2. This is what the concept. Image from mirror 1 will now behave like an object for mirror 2. So this is going to behave now like a positive direction, and this is going to behave like a negative direction. Now find the final position of the image. V2 is equals to u. कितना लिखोगे? u. This is the direct positive direction, and how much this distance is? 10 centimeter. So we'll write it plus of 10. What about the focal length? Focal length is going to come in negative direction, minus of 10. Divide by 10 plus of 10. It will become how much? It will become minus of 100 divided by 20. That means final answer will be coming as minus of 5 centimeter. If the calculations are correct, that means final image is not in this direction. It is minus of 5 centimeter. That means this 5 centimeter from the mirror to the final image position, I final, you will be having. This way you solve the multiple mirror cases. Take one at a time and then just solve it. Okay, 5 centimeter will be the answer. Final answer is 5 centimeter from the mirror to. Once you are taking the sign conventions correctly, then there is no problem. You will be easily understanding the thing. Okay. Now what is the graphical representation? Firstly for convex mirror, then we will see for concave mirror. This is the last portion that you have to understand, and majorly statement based questions are usually coming from here. What is the mirror formula? 1 by v plus of 1 by u is equals to 1 by f, and this curve that is drawn is between 1 by v and 1 by u. What is that y-axis? 1 by v, that means we will be saying y plus x is equal to some constant, that is c. For convex mirror, focal length is always positive. That means you will say intercept. Intercept is what? Always positive. So it can also be written as y is equals to minus of x plus of c. Minus of 1 is the slope. That means this kind of decreasing slope will be there. Minus of 1 slope. And intercept will always be positive. This is the intercept c, and it is equals to 1 by f. It is always positive. So you can draw this line that is drawn here. Now what are the important points that you have to understand here? What are the possibilities? So this line is actually reflecting what kind of images it always makes. See, for the first quadrant, here it is completely in depth, it is given. Please read it out. I am explaining for this case. For the next case, you have to understand from by yourself that how these things are happening. Okay, so you have to understand from yourself. Understand the first quadrant. First quadrant, u is positive. U is positive for a convex mirror. That means object is what? Virtual. इसको draw करके देखना. इसको draw करके देखना. You will be understanding. Object is virtual, and if and what about the v? U value is positive, v value is also positive. That means if the object and image are on the same side, if object is virtual, that means image is also going to be virtual, because both of them are in the same side. If all they are on the same side, either they will be real, either they will be virtual. Correct? Come to the second quadrant. Here what will be saying? That u is negative. That means object is real, but v is still positive. That means image is virtual. So this kind of possibilities is also possible in convex mirror. These are telling you about the possibilities, what kind of possibilities that you can have. See, third one, u is positive. That means virtual object, but v this time is negative. V negative, that means reflecting as what? It is reflecting you a real image. It is reflecting you what? A real image. That means this combination is also possible, that if you are having a virtual object, you can form a real image in case of convex mirror. So what is the case that is not possible for convex mirror? This case, quadrant 3. Quadrant 3, what is there? U is negative. U is negative means what? Real object. And V is also negative. That means real image. That means what you understand from here, from convex mirror, you can never make a condition that where object is also real and image is also real. This is the case that you have to understand. In convex mirror, you can never form this kind of scenario where the object is also real, where the image is also real. Let's see for concave mirror, because most of the ray diagrams we have seen for concave mirror. Concave mirror, again you will be writing the same equation, correct? Again you will be writing the same equation. What? 1 by v minus 1 by u is equals to 1 by f. Sorry, 1 by now it is y plus x. Now for concave mirror, focal length is what? Negative. If you have noticed, focal length is always taken as negative for concave mirror. That means it will be taken as negative intercept C. So it will be again written as minus of x. Slope will be again minus 1 minus of C. That means intercept is negative. Then in what is intercept? It is clear, na? The point at which you are going to cut the y-axis. That means from where you are going to cut the y-axis, it is going to be, this is intercept, that is C. It is always negative. And a slope is minus 1. That means this kind of line you will be having. So all these possibilities, again, you have to understand by taking one by one at a time. I'll be telling you what is a possibility that you can never make in concave mirror. First quadrant. First quadrant, what is V? Sorry, what about U? U is positive. U is positive. That means it is what? Virtual object. For virtual image, what is V? V is also positive. That means virtual image. That means in concave mirror, you cannot make or you cannot create a condition for a real for a virtual object. You cannot make a virtual image. Rest of the things, all the things you can make here. Real object, virtual image you can create, and in the ray diagram only I've shown you. Real object, real image, most of the cases it is getting formed. For virtual object also you can make real images. Okay, for virtual object also you can make real images, but for virtual object you cannot make a virtual image. So these kind of questions you can understand, and these kind of questions can come in the statement based questions. Okay, so I hope that you have enjoyed this session. We have understood the complete reflection of spherical surfaces in complete depth. Everything we have seen. Rest of the things are attached for reading purpose in the notes also. Okay, now it's about the practice question solving. Obviously optics is that kind of chapter that where you have to practice a lot of question. Okay, so just do the practice, honest practice, and until next time, keep learning, keep growing with Tapasya. Endigu and Dendigu Nama Tapasya.